Dear students, welcome to another lecture in Elements of Machine Design. Most of the students have joined the Google Classroom, but there are still some students who have not joined. Maybe around some 20 students or so are still remaining, because out of 125, 225, around 205 students have joined. So if you know anybody, any of your friends who has not yet joined, please ask them to join, uh, and ask them to attend all the online classes, because we don't know for how long we will have to learn this way through online lectures, and when physical classes will start, we don't know. It depends upon the government decision finally. So we hope that this coronavirus will soon, um, will be we will be able to overcome. We'll be able to find vaccine and medicines for this. But anyway, till that time, for us, what we should do is, in whichever state we are, we should be able to continue our studies and do all our work. Okay, one more thing I wanted to tell those people who have joined late. Say some students were asking me again and again, can we not uh, attempt the quizzes, the first, second, third, fourth quizzes like that? Okay, but you see, our attendance is based upon your solving the quizzes. You see, what I am assuming is you will see the video posted on that day, and then the quizzes are based upon those videos normally. So you will attempt those quizzes. So whoever attempts that quiz will get attendance, and that quiz is active only for one day. That means almost 24 hours. Okay, but because for the benefit of those students who have joined late, now what I'm saying is, I will make those four quizzes from the first four quizzes, that is quiz 1, 2, 3, and 4. I will make them available for you. So this Saturday today, Sunday tomorrow, and Monday, till Monday around 6 o'clock or something, I will keep them open. Whoever has not attempted before, you can give those quizzes and we will mark you absent. You see, this is one time benefit. I see, I will not be keeping all these quizzes active afterwards. Okay, so you tell those students to make use of it, this opportunity. And also the same thing, I will send a notice through the Google Classroom also. Okay, today let us come to our topic. We are discussing about creep, this phenomenon, creep. You see, the questions normally asked will be like this: what do you mean by creep? And explain different stages of creep with graph. Okay, what is creep? This also you may have already studied either in physics or applied mechanics. Okay, but anyway, let us have a short review of this. Creep is a slow and progressive deformation of a material with time under constant stress. You see, what we are saying is, you see, suppose we put load on a metal bar. You see, it will, what will happen? It may, its length, if we are pulling a metal bar with some load, its length may increase a little. You see, little means, it is so little that our eyes cannot see. It may be fractions of millimeter. Okay, only if with advanced accurate measuring instruments, precision instruments, if you measure, you may be able to find out that difference. Okay, so it will increase a little. That means an elongation in the length is taking place, which we call as delta L. Okay, and the moment we remove that load, what happens? It goes to its original shape, and its length will become again L. If it is initially we started with L, when we put load, it becomes length will be L plus delta L, and when we remove the load, it comes back to L. Okay, because that load is not so much that it has taken it to plastic state. But if the load is very much, it may go to plastic state. Okay, but we are talking about a stage where we are in elastic stage only. Okay, that means load is not so much, okay, that it has gone beyond the yield point. Okay, so now consider this state. You see, we have taken a rod and we have applied a load on it, that it is pulling. Okay, and that is we are in elastic state only. And what happened, we did not remove the load and left it like that, maybe for some days, and for some months we have left it. For some months, I'm saying, not few minutes or seconds. Okay, for some months we have left it, and when we come back after a few months and remove that load, what happens is it has not come back to its original length. You see, a permanent deformation has taken place. You see, even though the load is not so much to take it to plastic state, yet within the elastic limit stage itself, when the load is, not much that it should be in plastics range, still, because it was elongated, kept elongated for so long time, when the load is removed, it did not come back. So such a thing, such an elongation, such a phenomenon is called as creep. So this creep can be defined as slow. Slow means very slow. That we are talking about some days and months. Okay, very slow and progressive deformation of the material or material component with time under a constant stress. Okay, this phenomenon of creep is observed in metals, non-metals, as well as amorphous materials like glasses and high polymers. Okay, metals, except few exceptions like lead, exhibit creep at higher temperatures. And one more thing about high temperatures also. High temperatures, if something is loaded like that and the temperature in the atmosphere is more, okay, high temperature, then this creep, is clearly exhibited. Okay, whereas the materials like rubber, plastics are very sensitive to temperature, causing creep. Okay, we need not bother about rubbers, plastics. We will stick to metals. And so this is what happens. Okay, now what shall we do? Next, we'll come to the next thing. Okay, we to understand the phenomenon of creep completely, following diagram will be helpful. Here is a diagram. This diagram is called creep curve, and sometimes it is asked in the exams. You draw the diagram, creep diagram. Okay, so let us see. This is the creep diagram. You see, now it has it is x-axis is plotted is time and y-axis strain. This is creep strain or simply strain. Strain is on the y-axis and time is on the x-axis. Okay, now this is 0. That means okay, when zero time. Okay, suppose we have loaded it with some load. So what happens? Suddenly it elongates like this. Okay, see here it is shown from this line to this line. That means O to C is the instant deformation, which is called elastic deformation. That means what? The moment you put load, it is increased a little, and then if you remove the load, it will come back. Okay, suppose we kept the load, we left the load as it is. Then what happens? Then what happens is this we have kept it like that, and then time is passing. Now when the time is passing, see, it is, the curve is going like this. Okay, as the time is passing, you see, at 0 time this much was there. What is that? Strain, this much was there. Or you can simply say elongation also. Hmm. That is delta L also, this can be same. Okay, this can be plotted on the y-axis, or strain. Okay, because strain and delta L are proportional, because delta L upon L is strain now. Okay, so from C it is progressing like this along with time. See, and this goes like this for some time, some period of time, or you say some days. Okay, so it is like this. That means you can say a little sharp rise is there, and this stage is called as primary creep. Primary creep. Then when we reach D, from D to E, this is the secondary creep stage. Here, no, it was the slope is not so much. The slope has fallen. Okay, and this slope is less. That means, the rate of slope has reduced. It is slope of creep. The rate of creep is reduced. See here, the rate is much. That means in the primary stage it increases rapidly. Then the rate falls between in the secondary creep, and this secondary creep is for many days. Okay, and then we come to the point E, from where E to F, the tertiary creep. Tertiary means third creep, third stage. Primary stage means first stage. Secondary creep means second stage. Tertiary creep means third stage. In the third stage, again, it drops. It increases very steeply. Okay, that means what? A steep rise in the first stage, a steep rise in the second stage, and here this is a constant rate, or lesser rate compared to these other two stages. And then after some time, somewhere it may go and fail here. Okay, in the olden days, this in palaces, king's palaces, राजा महाराजाओं के घरों में वो मेटल के दरवाजे वगैरह कुछ बनाए. ओके, शुरुआत में वो दरवाजे वगैरह सब ठीक थे, मगर कुछ दिनों के बाद वो देखे हैं दरवाजा थोड़ा सा बेंड होने लगा. मतलब कुछ सालों के बाद वो बेंड होने लगा. ऐसा क्यों बेंड हो गया? हाँ, वो सही है ना. That is because of the creep. You see here now, when you are plotting the graph, this chart, only this time, this creep strain, this elastic deformation, that's much, and these points, you can write a C, D, E, F, or you can simply say O, A, D. Sorry, this is, instead of C you can call it A, this you can call B, this you can call C, this you can call D. See, we study this much only about creep. We need not go into further details about these terms also here. Okay, so uh, okay, that much only. Okay, now a little more, another point here. Okay, there is something. Okay, creep is a slow and permanent deformation when a part is subjected to constant stress at high temperature for a long period of time. This is the definition. But actually, there is no need of this term high temperature, because every time it is not, high temperature is not involved. Some cases it is involved, not always. Okay, this is useful. Creep is useful in designing internal combustion engines. Internal combustion engine means, I know, this motorcycle, car, and truck, buses, engines. Okay, IC engines, internal combustion engines, which run on petrol and diesel. Okay, useful in designing internal combustion engines. And boilers means, where mm, the steam, water is converted into steam. That is boiler. And turbines, where steam, from steam you get electricity. Okay, in those places where here boilers, turbines here, and IC engines, the temperature will be much. In these high temperatures, sometimes what is found is some of the parts over time they have elongated, and they started heating other parts. If there something is rotating, if a turbine is rotating, initially the turbine blades were not hitting the casing, but because of the creep, after some time they elongated and they started hitting the creep, started hitting the outer casing. That is because of the creep phenomenon. Okay, as in the figure, the piston is subjected to mechanical stresses as well as high temperature and thermal stresses for long time duration. Hence, we consider creep as criterion of failure for this application. You see, this is the piston. This is the piston. These are the walls. Okay. So while designing IC engines, creep is considered. Okay. As far as our subject at this diploma level is concerned, this is all we will learn about creep and not more. No formulae, nothing. We are not going to deal. Only that you understand what there is a phenomenon called creep. Okay. And mm, uh, okay, okay, today we'll see this much only, the creep. Okay, we'll stop here. Thank you.